तुम्हाला जर लक्षात आलं, कारण मी प्रेझेंटर झाल्यावर माझ्याला समजणार नाही कोण, ते फक्त मला मेसेज करा किंवा मध्येच मला सांगा कोण जर नवीन जॉईन असेल तर. ठीक आहे. We were discussing of pin out of 8051 microcontroller, and we have started discussion on that also. So today we will start again from basic. So if you consider, or if you look after pin out of 8051, then you will realize that we have uh, various packages available with us, or developers of microcontroller 8051 have developed various packages like DIP or QFN or PLLC, such a type of packages of microcontroller, which may contain, or which may consist of pins from 20 pin microcontroller, 40 pin microcontroller, or 44 pin microcontroller, or even more number of pins of microcontroller, as per as many features of microcontrollers the manufacturers have provided, that much uh, extra pins have been given on microcontroller. So if you look, there are 4 ports. Basically, typical microcontroller family consists of 4 ports, and those four ports are organized in symmetrical manner, or not symmetrical, sequential manner in 8051 microcontroller. Uh, if you look after any other microcontroller series, then you will realize that the organization of ports is not sequential. But here in 8051 case, all port pins are organized sequentially. This point to be noted, or this point is very much important.
सर आवाज ब्रेक होतोय तुमचं.
सॉरी.
हॅलो.
हॅलो.
हा
हा,
सर आवाज ब्रेक होत होता.
आवाज ब्रेक होतो का? ओके, ठीक आहे. आता येतोय ना?
हा सर आता
Hello.
येतोय.
Okay. So if you start from pin number 1, the pin number 1 will be allocated, or made available for port pin 1.0. Okay. So first 8 pins of microcontroller are made available or allocated to 8 pins, or 8 port 1 bits. For example, suppose we have port 1 to port pin number 1 to pin number 8, total 8 pins, and those 8 pins are allocated to port 1 bits. So pin number 1 will be allocated to port 1.0, 2 will be allocated to port 1.1, and similarly or sequentially, all other pins also allocated for each port bits. Okay, so we will have pin number 8 allocated to port 1.7. ओके. अजून एक तुम्हाला हे सांगतो, जर तुम्हाला माझी स्क्रीन दिसत नसेल तर तुमच्या साईडला पार्टिसिपंट्स तुम्हाला दिसतील, तर तिथं काय करा, मी शेअर केलेला ही विंडो, ते विंडोला पिन करून घ्या. राईट, त्याच्यावर प्रेस करून घ्या बटन, आणि पिनचा ऑप्शन येईल, पिन करून घ्या. म्हणजे फक्त माझी विंडो दिसेल, दुसरं कोणाची विंडो तुम्हाला दिसणार नाही त्या केसमध्ये. ठीक आहे. तेवढी एक सगळ्यांनी काळजी घ्या, म्हणजे तुम्हाला दुसरं कोणी हे करणार नाही, इंटरप्ट, दुसऱ्या कोणाची स्क्रीन इंटरप्ट करणार नाही. सो port 1 have only one function, which is nothing but we can make port pins, or pin number 1 to pin number 8 as a IO, means as a input pin, or we can make them as a output pins. So we have two provisions, or we can use port 1 only as a input port or as a output port. It does not have any alternate function. Okay, some advanced microcontrollers, sorry, advanced versions of 8051 or advanced family members of 8051 may support alternate function. For example, particular this pinout is showing MOSI, MISO, and clock. Means those pins can be used for some alternative function like SPI protocol implementing. Okay, but right now this part is out of our scope. That's why I'm not covering about this. Whenever SPI will be there, we will talk more about on it. Then pin number 9 will be reset pin of 8051. So before the sorry, in architecture of 8051, there while studying clocks, we have also studied reset. Okay, so why reset is important, or what is the role of reset, we have discussed already there. So this pin is connected here, and we can use external reset circuit, capacitor and resistor connected here, and which can be used for uh, resetting microcontroller. Okay, then pin number 10 to pin number 17, those pins are used for port 3. Pin number 10 to pin number 17, those pins are used for port 3. Okay, so uh, similarly, like port 1, we can use port 3 pins are also allocated as P3.0 to pin number 10, P3.1 to 11, likewise P3.7 to pin number 17. Okay, so if you look here, then you will realize that all port 3 pins have separate function or alternate function, but those alternate functions are separate for each pin. For example, port 3.0 have alternate function of RxD. Means whenever I am going to use uh, uh, 8051 for serial port or serial programming application, at that time we can use, or we can connect this P3.0 pin to any other device which is transferring. Means I will connect this P3.0 pin to receive data from other device. So this pin is, or the alternate function of this pin is the RxD. So I will be using for receiving data serially. Okay, uh, then P3.1, this is a TXD pin. This is also going to be used in serial communication. Whenever I will be, or whenever there is an application to transfer data from our microcontroller to external device, at that time we can use this TXD pin. Okay, so whatever data we want to transfer, this data will be transferred over TXD line. Okay, to receive data, P3.0 pin is used, and to transfer data, P3.1 is used. So don't confuse between those pins. Those pins, both pins have different functions, or both pins can be used independently. So there is no direct relation between them. Internally, whenever you receive or transmit data, both in both cases data will be received, or data will be transferred from SBUF register. So there is a limitation for transferring, but from pin perspective, both pins functions are different. Is it clear, all of you? Is this point is clear? Hello?
Yes, sir.
Okay,
Yes, sir.
so if you have any doubt or queries, you can interrupt me. Simply unmute yourself and ask me a question. Just a minute, someone messaged. Okay, then pin number 12 and pin number 13. Pin number 12 has simple its own function, simple port 3.2. means we can use this pin as an input pin as well as output pin, but it has alternate function of int0, means external hardware interrupt 0. Okay, so what it means, external hardware interrupts, interrupt, uh, we will be discussing in interrupt section, but I will give some idea about what is interrupt. So interrupt is nothing but any unwanted any unwanted disturbance or any unwanted or signal which is not expected or unexpected, which can occur at unexpected time. So uh, this those pins have made internal or hardware provision that any unexpected event can be detected using those pins. So there are two provisions for hardware interrupts, int0 as well as int1. So interrupt can be edge triggered or level trigger. We will discuss later about that. But port 3 can be used as a simple IO as well as it can be used for interrupt. Then next pins, port 3.4 and port 3.5, pin number 14 and pin number 15. These two pins also have function of timer 0 and timer 1. So these pins can be used as external clock pulse counting as well as we can use those pins for timer application also. Okay, and its own function is normal input or output. Then p3.6, which is allocate or which is given to pin number 16, is read bar, and p3.7 is, sorry, write bar, and p3.7 is read bar. So bar, what bar indicates? Bar indicates means whenever there will be active low signal, at that time this signal is going to be active. Okay, so for example, read bar means we microcontroller is going to be make this pin low for read operation. Write bar means microcontroller will write application. So okay, so in case those hello, am I audible?
Yes, sir.
Okay, those read and write pins are used in case of external memory interfacing for uh, we already discussed about, we can increase microcontroller's memory capacity to 64 kilobytes. So to increase our capacity of microcontroller, we need to use, or we need to add interface external memory to our microcontroller. So how we are going to do this? There will be, sorry, uh, we will have a memory, and to give memory signal that I am writing on memory, or to give memory signal that I want to read from particular location, we need to give read signal as well as a write signal to memory. So whenever we will be reading data from memory, microcontroller will send a read signal, and whenever we are writing on memory, microcontroller will give write signal to memory. So memory can understand that I need to do read function or write function provided on address by microcontroller. So we microcontroller have separate address bus. We will discuss in port 1 and port 2. Okay, so this is alternate functions of port 3. These are alternate functions of port 3, and uh, those functions are used at that particular application only. So you may have a question that how port 3 will understand that it is going to be used as a normal IO pin or it is going to be used as alternate function. For example, port 3.0 is used as simple IO, or port 3. Sorry, pin number 10 is used as simple port 3.0, or pin number 10 is used as RxD pin. So how it is going to uh, understand microcontroller that which function is going to be used? See, all those provisions are made in hardware. Okay, so whenever you are going to use normal IO application, microcontroller by default it makes it as a normal IO. Okay, whenever we will be using as a particular, for example, RxD or serial communication related application, we will be in serial control register, we need to make serial port enable. Whenever we will enable serial port, whatever data we will be placing, or whatever application we are developing related to RxD, P3.0 is by default going to be used for receiving data, or whatever data we are transferring, P3.1 or sorry, pin 11 will be by default used as TXT pin. So there is no any need to be care about how those pins will switch their functionalities from normal IO to its alternate functionality. It will be totally depends on our application. For example, I have to use serial port related application. For example, transmit signal or receive signal, I need to enable serial port. So whenever serial port is enabled, its alternate function is also enabled. Otherwise, your pins will be acts like normal IO pins. Is this point clear? Hello? Is this point clear? How microcontroller will differentiate between alternate function as well as normal IO port? Is this point clear? Hello?
Yes, sir.
Okay. So we will move towards next pins, pin number 18 and 19. So those pins are XTAL2 and XTAL1. Means here we can connect crystal, which is very much important to run microcontroller, because we can say it is heart of microcontroller. Without external clock or without clock pulses, microcontroller is not going to work. So standard operating frequency of 8051 microcontroller is 11.0592 megahertz. We can connect any crystal up to 40 megahertz, but standard crystal frequency is 11.0592 megahertz. So crystal is connected between these two pins. Both crystal pins are connected to a pin number 89, pin number 19. Then next pin is the ground pin. So what will be the function of ground pin? It will provide total IC layout, or whatever total IC chip signals are there, those signal or ground path to those signals. Okay, so this is again very much important pin of microcontroller, and in DIP package, pin number 20 is always ground pin, or in 20 pin package, pin number 10 will be also going to be a ground pin. So those are the complete left side pins of 8051 microcontroller. Now we will see pin number 21. So pin number 21 to pin number 28. So pin number 21 to pin number 28, those pins are used for port 2. Okay, but if you see the nomenclature or numbering of ports, then you will realize that 21 has numbering P2.0, 22 has numbering P2.1, and so on. Pin number 28 has P2.7. So means we can use those pins as simple IO pins, and those pins are reserved for port 2 applications. It has also separate dual function, or in not separate. It has combined dual function. We cannot use them separately. What do you mean by combine? Combine means all port 2 pins we need to combine to access its dual functions. What dual function is given to those pins? It has given dual function of higher order address. Higher order address. Higher order address is nothing but A8 to A15. So if you remember how address are how address bus is in 8051, then you will remember that, or recall that there is 16 bit address bus of 8051. So out of those 16 bits, higher 8 bits are reserved, or higher 8 bits are made available in port 2. Okay, so but for application purpose, all 8 bits are used at a same time. Likewise, in the case of port 3, each pin has its own separate dual function, but in port 2, dual function is there, but for dual function perspective, we need to use all port pins together to use as a address bus. Okay, but in normal scenario we can use these pins as a simple IO pins. And if you are using for addressing purpose, then you can use those pins to connect address of memory or any other device. Okay, then those are the pins which are used for special function pins. So those pins are have various functions. For example, this is program store enable, then this is ALE address latch enable, then EA external access. So those pins have various functionalities again. So if you are using external memory, then this pin number 30 will be used for address latch purpose. Whenever our multiplexed address and data bus will be carrying as a address, or whenever it is carrying data, we need to make differentiate. Okay, so how we will be going to differentiate? I will tell you after port 0. Okay, so those pins are used for to address latch. Then pin number 32 to pin number 39, those pins are allocated for port 0. But here remember, this sequence is in reverse order: P0.7, P0.6, P0.5, P0.4, 3, 2, 1, and 0. So pin number 39 is reserved for port 0.0 pin. And again, this port 0 has dual function, and this dual function is nothing but address. But it is again multiplexed address, so it is denoted as A for address, and sometime it can be also used for data. Okay, so while your microcontroller is carrying address, these pins are used as simple A0, A1, A2, A3, A4, A5, A6, A7, then A8, A9, A10, A11, A12, A13, A14, A15. Means our total 16 bit address bus. Okay, and whenever it is using for data, those port 0 pins will have function which is nothing but D0, D1, D2, D3, D4, D5, D6, D7, and port 2 will be acts like normal input output. Okay, so how microcontroller or how any other device will understand that at which point of or at which time instance there will be a address and there will be a data. So address latch enable, this pin will play a crucial role while differentiating this address or data. Okay, typically typically whenever those pins are carrying address, this address latch enable pin status will be high. So whenever this address latch enabled pins status will be high, means we can say that uh, this those pins of port 0 and port 1 will be carrying as address. See, ALE. So whenever ALE pin status is high, we will be having address on A0 to A15. What do you mean by A0 to A15? A0 to A15 means pin number 39 to pin number 32 and pin number 21 to pin number 28. Means those pins, those total 16 pins togetherly or combinedly used to carry 16-bit address for external memory. For example, I have interfaced external memory with my microcontroller and I want to perform suppose read or write operation. So whenever sorry, to perform any operation, first microcontroller will send address. So to differentiate from address or data, microcontroller will make this pin high so that our demultiplexing, we need to demultiplex here. Our demultiplexing logic can understand that right now we are having address on those pins, so those address is given to, or our demultiplexing logic will pass only address to address pins. Okay, then our read or write signal will be given to memory so that memory can understand that I want to make read function or write function on this particular address. Okay, for example, I have given address 0000 16 times 0, which is nothing but 000 H in hexadecimal. Okay, so this address is provided from A0 to A15, and suppose WR 16 pin has given logic low, low signal, because if you notice here there is a read, sorry, write bar, sorry, not read, write bar. So bar means we need to make this pin low. Whenever memory will receive this pin low, memory will see which address I am receiving. So memory will understand that I need to write on 000H address. So address is 00H and I have received a write signal. Okay, so what data I want to write? So memory will look data on data bus. This is nothing but address bus, and memory will look, just a minute. Are you seeing my screen? Hello, is it visible to all of you?
Yes, sir.
Okay. Yes, it's working. So, whenever there, sorry, after carrying address, during next clock cycle, immediately this ALE pin will go low. Okay. Next clock cycle, how we can detect? We will have clock cycles from crystal. So next clock cycle, ALE will go automatically low, and whenever ALE goes low, at that time our this multiplexed address and data bus will carry data. Means all those pins will act as or carry data from D0, D1, D2, D3, D4, D5, D6, and D7. So during ALE is high, our pins will carry address. Whenever ALE will be low, pins will carry data. So here we need to make a switch which will make whenever ALE is high, those data will be transferred to address, or ALE will be low, those data will be transmitted to only data bus of memory. So memory will understand that some data is going to return on that particular memory location, which is nothing but 000H location. And where I will have data, a microcontroller send me data on data bus. So memory will receive that data from D0, D1, D2, D3 to D7 pins and store on 00H memory location. Okay, is it clear how this demultiplexing is done in multiplexed and multiplexed address and data bus? Is it clear to all of you?
Yes, sir.
Hello?
Yes, sir.
Okay. If you have queries related to this, you can ask me. But for understanding purpose, just assume here because I have not explained this complete demultiplexing. But just you can assume that here we can use such a device which will transfer data whenever it will receive a control one. Okay, and it will block signals whenever it will receive zero, and since we have blocked it, signals are transferred from alternate line. Okay, then I just erase all those contents. Okay, so those are nothing but details of pin details of 8051 pins. So to use this microcontroller for any application, what we need to do is we need to perform, or we need to make some initial connections, or so that microcontroller will start working. So what are those minimum connections required to start microcontroller? So for as per our discussion, what will be the connections I need to do so that I can develop any small applications? So what will be the connections I need to make to start my microcontroller? Hello, hello.
Yes, sir.
So I want to. I have asked you all of you a question. Right now we have discussed complete DIP package of 8051 family. I want to make some application. For example, I want to make application to toggle LED. Okay. So to make this application, what connections I need to do to this IC so that my hardware will work fine or okay. Hello. जर मला ह्या मायक्रोकंट्रोलरचा यूज करून जर एखादं ॲप्लिकेशन तयार करायचं असेल, तर ह्या आय-सीला हार्डवेअरमध्ये काय-काय कनेक्शन्स केले पाहिजेत, की जेणेकरून तो माझा जे काही ॲप्लिकेशन आहे, ते सुरू होईल? कमीत कमी काय कनेक्शन्स केली पाहिजेत, कोणत्याही ॲप्लिकेशनसाठी? तरच माझा मायक्रोकंट्रोलर चालू शकतो.
Receiving data, transmitting data,
रिसीव्ह डेटा, ट्रान्समिटिंग डेटा. ओके.
परत ना एक्सटर्नल क्लॉक 18 and
एक्सटर्नल
19
क्लॉक. ओके.
पोर्ट पिन इनपुट पोर्ट
ओके. Anyone? Any other one?
ग्राउंड ग्राउंड पिन
VCC ground.
VCC ground. Those are the important connections to make a minimum connection. Okay. So I will make here a diagram. So I need to connect this pin to VCC. Okay. VCC. Then P2 ground.
सर वॉइस ब्रेक होतं.
What is it? आता
हा येतोय.
हा. So first I will connect this VCC pin to plus 5 volt power supply. Pin number 20 to ground of my hardware. Then pin number 18 and 19 I will connect my crystal. So how my crystal is going to be connected? Suppose this is my crystal. I will connect those pins of crystal to pin number 18 and 19, and I need to use some compensation capacitors to work crystals fine. So those capacitors can be 33 picofarad capacitors, and other pins of capacitors are also grounded. Okay, then I need to connect reset circuit, because to work microcontroller fine I need to hold a reset at logic. So reset circuit will be a microfarad capacitor and 10k resistor, and resistor's second pin is also grounded, or we can connect, sorry, I will erase. So I can use a resistor. Don't confuse here, I am drawing resistor symbol, and I can use connect this resistor to ground. So this capacitor is going to be a 10 microfarad capacitor, micro, sorry for drawing, and 10k resistor. Okay, so to make reset provision I will connect here a switch across capacitor. Okay, and I will connect this capacitor to reset pin. Alternate pin of capacitor will be connected to plus 5 volt. Okay, is it properly visible to you?
Yes, sir.
Hope it is properly visible. Then I also need to connect this EA, external access pin, to VCC. Why? Because whenever I am using this EA pin to VCC, I am telling microcontroller that in this particular case, I am not connecting external memory to our microcontroller. Oh, okay, so I will connect this pin to VCC. So those all functions will be eliminated. Okay, since I am not connecting, or sorry, I'm connected this pin to VCC. I have told microcontroller that I am not connecting external memory to my microcontroller. So since external memory is not connected, our port 0 and port 2 pins alternate function, which is nothing but address and data, will be disabled, as well as those read write case. In case of memory, read write signals are also disabled, or ALE signal is also disabled, which is not going to be used. Or if you want to connect external memory, then we can connect those pins, sorry, this pin to ground. But in our all regular application, we no need to use external memory, so we will connect this pin to VCC, because those whatever memory, on chip memory of microcontroller is enough for us for programming perspective. Okay, so this is nothing but minimum connection of 8051. Oh, VCC, sorry, pin number 40 and pin number 31 both are connected together and connected to 5 volt power supply. Pin number 20 is connected to ground. Pin number 89 and 19 are connected to crystal through, sorry, and crystals alternate pins are also connected to 33 nanofarad, sorry, picofarad capacitor, and alternate pins are also capacitor are connected to ground. Pin number 9 is connected to reset. And how reset circuit is designed? 10 microfarad capacitor is connected to resistor, and resistor is next terminal of resistor is connected to ground, and across resistor uh, we will have a reset signal. And to reset microcontroller we can use uh, a switch across capacitor. So whenever we will press a switch, this capacitor will discharge through this switch and resistor, and whatever discharge time, uh, and we will so discharge, we have adjusted discharge time in those values of resistor and capacitor, so that this voltage at this particular pin will be held high to one machine cycle. Okay, we know that capacitor can be charged, capacitor can be controlled charge or controlled discharge. So whenever I will press that switch, capacitor will discharge through this path likewise. Okay, but since there is a resistor, it will not discharge instantly, it will take certain time, and we have adjusted this value of resistor and capacitor such that we will have at least one machine cycle held at particular potential. Otherwise, since this switch is open and capacitor is connected here, in normal scenario our reset pin will have logic 0. Okay, so as we have already studied, reset in 8051 is active high. Okay, so what do you mean by active high? When you provide high logic, at that time only microcontroller will reset. Okay, so how we will provide a high logic? In that fashion. Is it clear, all of you?
Yes, sir.
So pin diagrams and minimum connection is clear to all of you. So if you connect those pins and accordingly, then you can easily develop any application to microcontroller. So again, to write program you need to make separate provisions, but we will discuss later. If this point is clear to all of you, then
Yes,
we
sir.
can have some discussions on this. So if you have any discussions regarding, then please or queries regarding today's point or any previous point, then we can have a discussion. Please, so ask if you have any queries.
Sir, in this block diagram is last year BSc third year, na?
Yes, yes, yes.
Relay circuit.
Actually, uh, which block diagram you are asking about me?
Relay circuit, DC motor, stepper motor, similarly
No,
to
no, 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 no. Yes, yes, yes. Yes, you can use any application, but to drive any application or to make run any application, we need to have minimum connection associated with it, or we need to make minimum connection. So your application may be LED, your application may be DC motor, your application might be stepper motor, or your application can be a
seven
any high
segment
end
display.
application, 7 segment display, LCD display, keyboard, anything. Whatever you want to do, you can't do without this minimum connection. If you miss anyone from those things, then your application, sorry, your circuit hardware is not going to be worked as you are expecting. Okay, so whatever application is there, you need to do this minimum connection. Okay, I hope you understood.
Yes, sir.
Okay, anyone? So I will give you today a task, as you have mentioned. Draw application circuit diagrams for. So I will also post this task in Google Classroom. Draw application circuit diagram to interface single LED to any port pin. But here I am expecting a minimum connection with LED connection. Single LED I want to make, sorry, single LED I want to make interface with microcontroller. So you have to draw. Then second, again draw circuit diagram for LED as well as optocoupler, and one more for DC motor. Okay, so only I am expecting only one device, means only one LED, only one relay, only one optocoupler, or only one DC motor. So you need to draw a minimum connection, plus for LED application you need to draw LED circuit or LED compensation circuit. For relay case, same. Okay. Problem is clear to all of you?
Yes, sir.
Yes, sir.
Okay.
Sir,
So if you have any other queries, then please ask.
so last lecture,
Hello.
how to work set a instruction in microcontroller.
How to
Work set instruction in microcontroller.
how set instruction will work in microcontroller?
Uh,
सेट इन्स्ट्रक्शन कशी काम करते मायक्रोकंट्रोलर मध्ये असंच
uh, yes, sir. लास्ट लेक्चरला तर
अं,
मी सांगितलेलं ना ते सेट इन्स्ट्रक्शन इन म्हणजे मूव ए कॉमा हॅश 50 याचा ऍड्रेस दिलेला तो आपण ह्याच्यामध्ये हे केलेला नंतर सेट इन्स्ट्रक्शन तुम्ही दिलेली ती
okay, so see, in last we have discussed beat addressable as well as byte addressable. Okay, so what do you mean by beat? Beat means normal single just logic 1 or logic 0. What do you mean by bit? Any logic 1 or logic 0 is nothing but single bit. And what is byte? Group of ones or zeros or mixture of ones and zeros is nothing but byte. But how many bytes, sorry, how many bits are there in byte? There are 8 time 1 or 0. So I am hello.
येस सर
Sorry for interruption. So in this particular case, this complete is a byte, which contains 4 bits. This is single particular bit. This is single bit. This is single bit. This is single bit. But we are combining together in microcontroller or any digital system, so that for accession purpose we will have a simplicity. I can't remember all those bits individually, but if I combine those bits and I make a hexadecimal number or a representation of this, then I will have a number which is nothing but f0. So for calculation purpose or for my accession purpose, I can easily write or read this f0. But each and every time if I need to write 8 bits, then it is quite tedious task. So we have grouped uh, a group of 8 bits to bytes. Okay, and for representation purpose we are using a hexadecimal number system. So what happens when we are using bit level instruction? Because there are some registers which can be accessed. For example, all port registers can be accessed as using bit level instructions as well as byte level instructions. So to set particular bit, I can use instruction like set b. Suppose I will use here p0.1. Okay, so what it means, I will be setting or set microcontroller port 0.1 bit to logic 1. So this instruction will perform only on single bit. Hello.
येस सर
Am I audible? Huh. This
Yes, sir.
instruction, set instruction will work on only single bit. Okay, so it will make only this particular pin P0.1 pin is equal to 1. Sorry, this particular pin will make 1. Okay, or if you use clear instruction CLR P0.0 means we will make this particular 39 pin as a 0. Okay, but what happens in case of byte level instruction? Whenever I will be using move a comma, or sorry, move, I will write P0 here. I can't write P0.1 because move will use complete group of 8 bits. So if I am transferring 8 bits to you, then you must have a ability to receive 8 bits. You cannot receive all 8 bits in single bit place. Okay, for example, I am transferring these 8 bits to you and you have only one place to receive. How is it is it possible to receive all bits in one place? If you receive serially, then you will have only stated last bit. Okay, but I want to send those bits parallelly. So for parallel purpose, you need to have 8 bits at receiving end also. So whenever you will use move instructions, at that time you will use complete port, nor not single bit. Okay, this is the difference. I will be using complete port in case of move, and in case of single bit instruction I need to give particular bit because I will be change only that particular bit. Clear?
Yes, sir.
Or is there any doubt? Any more doubt?
No, sir.
So
आणि T0
huh.
T0 आणि T1 म्हणजे ऍज अ
Hello.
टायमर काउंटर म्हणून यूज करतात ना.
T0 and T1 timer and application.
म्हणजे आपण त्यातून एखाद्या आपल्या ऍप्लिकेशनला टाइम डिले देऊ शकतो त्या पिन यूज करून.
Not time delay, but those pins are used to count external clock events. In case of counter, see, for example, I am using design application as a counter. For counting purpose, I need to have some pulses. Then and then only I can able to count. Nah? So what things I am going to count? We are in digital. So in digital, we only understand logic 0 or logic 1. Okay, and this series or sequence of logic 0 and 1 is nothing but clock pulse. So for counter case, we can only able to count pulses. Okay, and in timer case, actually we are using internal clock pulses which are obtained from uh, our crystal or internal clock source. Okay,
ओके सर.
is it clear?
Yes, sir.
येस सर.
Okay, so I will stop today, and there will be second lecture from which will be conducted by Shinde sir. But from today onwards, we will be conducting lecture only on uh, Google Meet as per our college policy. So do join lectures on Google Meet, and if you have any problems to join lectures, then again discuss with us so that we can easily sort out all your problems. So right now I'm leaving this lecture. Shinde sir, over to you.
Mangesh.
Good morning, all.
Good morning, sir.
So, very warm good morning to all, and welcome you all to Google Classroom. So, I thought you all are get acquainted with this Google Classroom platform. Now onwards, we conduct all your lectures as Paul sir had told you according to new timetable from 9 a.m. to 11 a.m. Okay, and platform is Google Meet. Still, we until now we have used Zoom platform. Now onwards, we are moving towards Google Meet. Okay, so okay, fine.
Yes, sir.
Okay, so we quickly take a revive. Mrunal Dikshit, we quickly take a review of what we have learned until now. So until now, uh, in digital signal processing, we covered some introductory part related to digital signal processing, which is classification of signals. Also, one important part which we have covered is sampling theorem. Last time we discussing about what is sampling theorem. Okay, so sampling theorem, as we last time discussed, is nothing but sampling frequency fs should be equal to or greater than message frequency. Okay, fs should be greater than twice that of message frequency. Okay, so that is about sampling theorem. So why sampling theorem is important, that is also one important point that we also covered, that we want to recover signal, means continuous time signal. By using sampling theorem, we convert it into discrete or digital signal. Then we have to recover that discrete time signal again to continuous time signal. So for that reason, we need some rule or some formula which can be used to recover the original signal. Okay. Okay. So this is about what we have covered until now. Now from this lecture, we're going to start another part of topic number 1, that is so from this lecture we start with another important part, that is system. So until now we covered what is signal? So signal is nothing but there are independent and dependent variables. Okay, now what is system? How we define system? So signal and system. So first going to revive what is system. So how we define system? Are you able to see my screen?
Yes, sir.
Okay, what is on screen? Is there presentation?
No, sir.
Just minute. So anybody from you can elaborate what is about system?
Sir, the physical device that performs operation on signal is known as system.
The physical device which perform
Operation on signals.
operation on signals is called as system. Okay. So system is nothing but what physical device which performs certain operations on signal. So in system, if we consider box, system is box, then at the input of that box there will be signal. Okay, and at the output there are signals but with certain operations which are specified for that. Okay, now now if system, if we want to classify the systems, then systems can be classified as same as signals are classified into continuous signals and discrete signals. Now how we can classify the system? Whether systems are continuous system, discrete system. So one important part from system is linear time invariant system, that is LTI, and these are very important part in system which we have also studied in MSc first signals and system. बरोबर है?
Yes, sir.
So what is time variance? I'm unable to share my screen. Okay, just a minute. Huh? काय झालं, मी गुगल क्रोमच्या ऐवजी मोझिलावरून लॉग इन झालोय, त्यामुळे स्क्रीन शेअरिंग त्यानं ब्लॉक करून टाकलंय. जस्ट मिनिट हा. Are you able to see my screen?
Yes,
Okay,
sir.
screen दिसतंय तुम्हाला?
Yes.
Okay. So in systems, so until now we have covered all this part. Now we are moving towards system. So before going deep into the systems, just introductory part related to system. So in signals, we have classified signals as continuous, discrete, even, odd, also various applications on signals. Now our interest is in discrete time systems. So there are also continuous and discrete time systems. So we are interested in that discrete time system. Okay. So this is block diagram as we defined. System is nothing but physical device which can perform various operations. So there is input and output. So here, if xn is input to the signal, xn signals are input to the discrete time system, then yn is output of that system. So xn is input signal, or it is also called as excitation, which is given to that block which is discrete time system, and we got output which is equal to yn, and which is output signal or response. It means to any system, if we provide certain input signal or excitation, then we got some output signal or a response. So instead of input signal and output signal, we can say excitation and response. Now mathematically, if xn is input and yn is output, then what is function of system? So this equation defines. Okay, so that symbol operator tau is called as transformation. So this transformation is function of system. It means system transform input signal or excitation into output signal or response. So yn is equal to tau x of n. It is function of system. So tau is function, okay, and which is called as tau, that is operator which is called as transformation, which perform certain operations on input, and we got output yn. Okay, we solve this with one example. So any input signal xn is transformed to yn with that system. Okay, so simply take one example, that 2.21 determine the response of following system to the input signal. Are you able to hear me?
Yes, sir.
Yeah. And screen is visible to you?
Yes.
Okay. So write down that example, following system to the input signal. Now here we have for any system, so consider our input signal xn is what here? Xn is equal to magnitude n, which is -3 to +3. It means n lies between -3 to +3, and we only take its magnitude. Okay, we don't consider here sign. Okay, so xn magnitude n, which is from -3 to 3. Now how that is represented? Xn is equal to, from here it start 0, 1, 2, 3. N lies between 1, 2, 3 and 1, 2, 3, and otherwise it is 0. म्हणजे इथे त्याच्या व्हॅल्यू काय आहेत? +3 and -3 पर्यंत. आता ह्या -1, -2, -3 पण आपण कन्सिडर करू शकलो असतो, but we here only take magnitude, that's why it is 1, 2, 3. हे लक्षात येत आहे ना तुमच्या? म्हणजे ही जो डिस्क्रीट सिग्नल आहे एक्सएन, हा रिप्रेझेंट कसा केलेला आहे पहा. हा -3 टू +3 पर्यंत व्हॅल्यू होते, म्हणजे 1, 2, 3 असं त्याचं काय आहे व्हॅल्यू आहे. बट ऍज we only going to take its magnitude, that's why at the left side we take 1, 2, 3 instead of -1, -2, -3. आता या 3 आणि -3 पर्यंत फक्त ह्याच्या व्हॅल्यू आहेत, अदरवाइज ही व्हॅल्यू काय आहे? 0. हे रिप्रेझेंटेशन लक्षात आलं तुमच्या? ओके. आता पहिलं काय आहे पहा, हा सिस्टीमचा रिस्पॉन्स. डिटरमाइन द रिस्पॉन्स ऑफ द फॉलोइंग सिस्टीम टू द इनपुट सिग्नल. आता पहिलं काय आहे पहा, yn हे आउटपुट आहे, इक्वल टू xn. म्हणजे xn काय आहे? 0, 3, 2, 1, 1, 2, 3. ओके. आता हा पहिला जे आउटपुट आहे yn, हे सेम ॲज काय आहे? xn. बरोबर आहे का? ओके. It means yn which is equal to xn. So there is no transformation. It means no operation performed by system on input signal xn. Okay. Now b. What is b? Yn is equal to xn minus 1. Now here system performs which operation? Shifting operation. बरोबर ना? म्हणजे तो काय आहे आता इथं शिफ्टिंगचं फंक्शन करतोय ना. मीन्स हा डिले करतोय ना. -1 म्हणजे काय होणार? तो डिले होणार, एक ने शिफ्ट होतोय ना. बरोबर. मग आता हा डिले झाल्यानंतर काय होईल पहा, एक ने इकडे शिफ्ट झाला ना. बरोबर आहे का नाही? म्हणजे आता ट्रान्सफॉर्मेशन काय झालं, तर शिफ्टिंग ट्रान्सफॉर्मेशन झालं टू द लेफ्ट साइड. ओके. नेक्स्ट yn इज इक्वल टू xn प्लस 1. मग एक ना काय झाला, तो शिफ्ट झाला राईटला. ओके. म्हणजे आता ट्रान्सफॉर्मेशन म्हणजे सिस्टीमचं फंक्शन काय आहे, हे ना शिफ्ट केलं टू द राईट साइड. ओके. आता पहिलं 3 बघा फक्त. ए काय आहे, म्हणजे सिस्टीमनं काहीच परफॉर्म केलं नाही ए मध्ये. yn, it means output is same as input, means yn is equal to xn. ओके. हे लक्षात आलं तुमच्या? ए मध्ये आउटपुट जो आहे yn is same as input, that is xn. It means excitation and response is same, so there is no function performed by system. ट्रान्सफॉर्मेशन काय झालेलं नाही. दुसऱ्या याच्यामध्ये सिस्टीमनं काय केलेलं पहा. म्हणजे आता सिस्टीमचं फंक्शन काय आहे याच्यामध्ये, अशी सिस्टीम आहे की ज्या सिस्टीमला इनपुट xn दिला आणि त्या सिस्टीमचं फंक्शन काय आहे, तर इनपुटला त्यानं शिफ्ट करायचं एकनं. बरोबर ना? लेफ्ट साइडला. बरोबर ना? n-1 इट मीन्स 1 न तो शिफ्ट होणार आहे लेफ्ट साइडला. ओके. म्हणजे आता सिस्टीमचं फंक्शन काय आहे, शिफ्टिंग करणं. म्हणजे ट्रान्सफॉर्मेशन काय करतोय, तो शिफ्टिंग करतोय लेफ्ट साइडला. नेक्स्ट yn इक्वल टू काय आहे आता xn+1 म्हणजे आता सिस्टीमचं तो काय आहे इथला तर 1 न शिफ्ट झाला राईट साइडला. ओके, म्हणजे शिफ्टिंग झालं 1 न. मग सी मध्ये हे या 3 गोष्टी लक्षात आल्या तुमच्या. आता या 3 म्हणजे ह्या एक्झाम्पल मधून ह्या 3 याच्यावरून सिस्टीमचं फंक्शन लक्षात आलं तुमच्या. पहिल्या याच्यामध्ये सिस्टीम ऍज म्हणजे सिस्टीमनं काहीच केलेलं नाही. दुसऱ्या याच्यामध्ये सिस्टीमचं फंक्शन काय आहे टोचं, तर त्याने 1 न शिफ्ट केलं. दुसऱ्या याच्यामध्ये पण शिफ्ट केलं. एका ह्याच्यात लेफ्टला शिफ्ट झाला, एका ह्याच्यात राईटला शिफ्ट झाला. ओके, एनी डाऊट? हॅलो,
Yes, sir.
एनी डाऊट?
No, sir.
एनी अदर? बाकीच्या सगळ्यांना समजलंय का हे?
सर अजून एकदा सांगा.
अजून एकदा सांगतो. हे बघा, आता इथं आपण काय केलेलं आहे पहा. सिस्टीम म्हणजे काय आहे पहा, तर सिस्टीम इज नथिंग बट फिजिकल डिव्हाइस विच फॉलोज दिस इक्वेशन yn इज इक्वल टू टो एन. बरोबर, म्हणजे yn हे आउटपुट आहे किंवा आपण त्याला रिस्पॉन्स म्हणतो. xn हे आहे इनपुट सिग्नल किंवा त्याला एक्सायटेशन म्हणतो. आता या इनपुट सिग्नल वरती हे सर्टन ऑपरेशन करतोय. हे ऑपरेशन इज नथिंग बट फंक्शन परफॉर्म्ड बाय सिस्टीम. बरोबर ना, म्हणजे ट्रान्सफॉर्मेशन करतोय. म्हणजे इनपुट वरती सर्टन ऑपरेशन म्हणजे ट्रान्सफॉर्मेशन केल्यानंतर जे आउटपुट मिळतंय दॅट इज फंक्शन ऑफ सिस्टीम. ओके, म्हणजे मॅथमॅटिकली आपण ते रिप्रेझेंट केलं. आता फॉर एक्झाम्पल हा बॉक्स म्हणजे आपली सिस्टीम आहे. बरोबर, त्याला xn हा डिस्क्रीट सिग्नल, आता डिस्क्रीट टाइम सिस्टीम बघतोय आपण, त्याला xn हा काय दिला, इनपुट म्हणून दिला. ओके, ड्यू टू दॅट xn system performs certain operation that is transformation on it and we got output yn. ओके, मग आता ट्रान्सफॉर्मेशन काय असेल तर व्हेरियस ऑपरेशन्स म्हणजे शिफ्टिंग असेल, मल्टिप्लिकेशन असेल, ऍडिशन असेल किंवा व्हेरियस ऑपरेशन, ते ऑपरेशन त्या सिस्टीमला परफॉर्म करणं म्हणजे काय करणं, ट्रान्सफॉर्मेशन करणं. येते लक्षात? तर हेच आपण एका एक्झाम्पल हे करतोय की या एक्झाम्पल मध्ये xn हा डिस्क्रीट सिग्नल आहे आपला की जो आपण एका सिस्टीमला देतोय. बरोबर, मग काय करतोय आपण पहा, xn काय आहे माझा इथं, xn लाइज बिटवीन -3 to 3 म्हणजे -3 to -1 0 1 2 3 असे आपलं काय येतील त्याच्यातले व्हेरिएबल्स येतील. बट वी गोइंग टू टेक ओनली मॅग्निट्यूड, म्हणजे मॅग्निट्यूड n घेतल्यामुळे काय झाला मग तो ही सिस्टीम अशा पद्धतीने रिप्रेझेंट होईल. 3 2 1 म्हणजे -1 -2 -3 ची ऐवजी 3 2 1 0 1 2 3. अदरवाइज काय आहे, या 3 च्या पलीकडे तो काय -3 to 3 च्या पलीकडे त्याची व्हॅल्यू काय आहे 0, म्हणून या व्हॅल्यू काय आल्या 0. हे झालं आपलं xn. पहिल्या प्रॉब्लेम मध्ये काय आपल्याला yn इज इक्वल टू xn म्हणजे रिस्पॉन्स इज सेम ऍज एक्सायटेशन किंवा इनपुट आउटपुट सिग्नल इज सेम ऍज इनपुट सिग्नल. म्हणजे आता yn इज इक्वल टू काय मिळाला आपला, सेम ऍज xn. बरोबर, दुसऱ्या याच्यामध्ये काय आहे पहा, तर yn इज इक्वल टू xn-1 म्हणजे लेफ्टला तो शिफ्ट करतोय आपण 1 न. ओके, मग लेफ्टला शिफ्ट केला म्हणजे काय होता, ओरिजिनली आपला सिग्नल इथं आहे 0 ला ओरिजिनेट होतोय, मग तो 1 न इकडे शिफ्ट केला म्हणजे तो कुठं होईल 1 ला जाईल ना. मग ह्या सिस्टीमचा रिस्पॉन्स म्हणजे दुसऱ्या याच्यामध्ये ह्या सिस्टीमनं त्याच्यावरती ट्रान्सफॉर्मेशन काय केलं तर 1 न शिफ्ट केला. आता हा जो रिस्पॉन्स मिळालेला आहे yn इज इक्वल टू, तो म्हणजे काय झालं, सिस्टीमचं फंक्शन झालं. आता नेक्स्ट याच्यामध्ये काय केलेला आहे, तो शिफ्ट केलाय बट टू द राईट. इट मीन्स ट्रान्सफॉर्मेशन इज xn+1. ओके, ह्या 3 गोष्टी लक्षात आल्या तुमच्या? एनी डाऊट, एनी क्वेश्चन?
Yes, sir.
आता नेक्स्ट तुम्ही सॉल्व्ह करताय काय, yn इज इक्वल टू 1/3 xn+1 प्लस xn प्लस xn-1. आता हा रिस्पॉन्स मिळवायचा आहे तर त्यासाठी काय काय करायला लागेल बघा बरं. मग म्हणजे तिन्हीचं कॉम्बिनेशन करायचं ना, xn -1. म्हणजे आता सिस्टीमनं आतापर्यंत काय केलं होतं, फक्त ट्रान्सफॉर्मेशन एकदा सेम, एकदा हे, आता एकदा हे. आता हे कॉम्बिनेशन आहे सगळ्याचं, म्हणजे सिस्टीम काय करते, हे कंबाईन करते सगळं. मग काय आउटपुट मिळेल आपल्याला, yn इज इक्वल टू व्हॉट, हा एक्सरसाइज म्हणून घेतोय, असाइनमेंट घ्या किंवा एक्सरसाइज घ्या. ओके, कुणाचे काय डाउट्स आहेत का? लास्ट जे होतं डी, ते आपण काय करणार आहोत, असाइनमेंट म्हणून घेणार आहोत. ओके, एनी डाउट, एनी क्वेश्चन? Okay, so in this lecture, until now, we have just introduced about what is system and how operation can be performed on system. This in detail we have studied in MSc first, that is signals and system, in paper signals and system. We just revised it for discrete time system. It means only we considering discrete time systems. Okay. Now, as signals, we going to classify systems also. So, how we classify systems? First, as continuous time systems and discrete time systems. Our focus is on discrete time system. Now, important part in any system is linear time invariant system. Okay. So before that, we have to study what is time invariance, variance and time invariance. काय आहे मग तो? त्याच्या अगोदर आपल्याला सिस्टीम रिप्रेझेंट कशी करायची हे पण बघायला लागेल ना. सो क्विकली वी सी हाऊ सिस्टीम कॅन बी रिप्रेझेंटेड. Hello. So quickly we going to study how system can be represented at next lecture. Still you solve that assignment until tomorrow. We will stop here. At next lecture we going to study how system are represented and classification of system. Okay. आजच्या याच्यामध्ये काय अडचण आहे का कुणाची?
नाही सर.
ओके, थँक्यू.
हॅलो. झोपा जाऊन आता घरी.
झोपा म्हणजे काय? सकाळी झोपला मेसेज आलाय. सकाळी झोप 9:30ला उठलोय आणि बघ तुझे मेसेज आलाय 9ला लेक्चर.
अजून आंघोळ करायचे
पोळ सरांचं झालं का लेक्चर?
झालं की.
काय घेतलं त्यांनी?
काय 8051 मायक्रो कंट्रोलर घेतलं.
ते किती उशीर झालं लेक्चर?
अर्धा तास.
कोण कोण होता तुम्ही?
4 जण होतो आम्ही. हा,
कोण कोण?
मी, रवी, मंगेश आणि अक्षय गुजर.
अक्षय
स्क्रीनशॉट मारलं का?
अरे स्क्रीनशॉट
दिवस कुठं उजाडला?
स्क्रीनशॉट नाही मारायचे त्याच्यात आता. डायरेक्ट प्रेझेंट जाते.
फोन उड्या मारत असतील. आता चक्क आला.
काय पुन्हा काय मारलाय
रेकॉर्डिंग होते काय?
बरं तू सांग बघ तू. हो
रेकॉर्डिंग चालू आहे.
कल्याण सर.
प्रेझेंटी कशी लागते पण यात?
फोटो दिसतोय ना का तुझा, मग लागल की.
काय बोलू नका, रेकॉर्ड व्हायला लागेल.
आता मी गेली, मी बोलली होती. आता ते झूम इनचा डिलीट मारायचं
झालं.
होय ऍप.
हो, आता
ती
झूम
परत
डिलीट मारा.
घरी पप्पा म्हणजे
बरं
पप्पा
झालं.
कुठं बाहेर गेले की हे करायचं त्यांच्यावर मी करायचे.
स्क्रीनशॉट सेंड कर तेवढं सरांचे.
कशाचं ग?
ते पोळ सरांचे.
नाही मारले ना रोहित?
रवीने मारलेत ना?
मारलेत.
द्या द्या
सेंड
मग.
कर.
आधी रोया होता का विचार रोयाला.
होता की.
अरे होते की राव्या,
नव्हता
काय
सोय.
लागा चेष्टा करायला लागला. होतं की काय नाही, मायक्रो कंट्रोलची डायग्राम ती स्क्रीनशॉट मारली असेल रवी.
मायक्रो कंट्रोलरचे नव बाबा, फॅमिली ऑफ मायक्रो कंट्रोलर.
तीच ती फॅमिली आणि काय तर ड्युएल पॅकेज म्हण.
फॅमिलीत आणि तुझ्यात फरक आहे का नाही, तुझी फॅमिली तू एकटा.
असं ते.
माझे म्हणताना काही सांगू नकोस, आपलं ते वय वय
अरे
म्हणते.
नाही अरे लागतं.
झूमच बरं होतं काय, त्यात ऑनलाईन
ए
झाले
कशाला
त्याच्यामुळे
झूम
आता
बरं
काय.
होतं, देशद्रोही कुठली, कशाला तुला चिंच ऍप पाहिजे गे.
चल गप.
जाऊ दे की, बरं
नको
झालं
नाटकं
झूम इन
करू.
टळलं ती. हे गे बी.
कोलपे चीनचीच आहे तर.
हा बरं असू द्या.
सगळं बंद व्हायला पाहिजे चिंच.
लेफ्ट हो चिंचे बंद हो.
ए आपण फक्त किती जण राहिलोय
नाटकं
माहितीये
नको
का,
करू.
4 राहिलोय.
हो की लेफ्ट तू बी.
तू पण हो
कोण?
की.
तुला दीक्षितला म्हणायचंय का असं?
ए गप्प आहे.
तुला दीक्षितला असं म्हणायचंय का?
काय म्हणू उगाच आपलं सिन्सिअर मुलींना काही म्हणत जाऊ नको.
तू जा आता काम कर जा.
इथे का बांगलाय
बरं
आमचा
अरे,
उस
चांगलं ऍप आहे म्हणजे.
कोळप्याला नाही, कोळप्याला चांगलं खुरपायला येतं.
₹250 हजेरी आहे, 200 देतो.
मला तर माहितच नव्हतं लेक्चर आहे. मी आज लवकर उठल्याहून बरं, नाही तर मी नाही उठत एवढ्या लवकर.
तुला त्या मांजरातनं काय
तर
सुचलं
वाट
तर तू
लागलेच.
लेक्चर करते.
माहिती बाबा, मांजरं मम्मी नाही घेऊन देत.
अरे आपण चौघच आहे या.
अरे रेकॉर्डिंग चालू आहे.
बंद कर की रोहित तेवढं.
नाही
अरे
होत
मला नाही
तसं.
येत बंद कर. नाही चालू. गेलं.
चालू आहे दाद्या.
नाही होत बंद.
हे हो याला पाहिजे. उगीच सरासनी ऐकायला.
कोलते सांग की आज काय काय लेक्चर झालं समजावून. व्हॉट इज सिस्टीम.
कोळपे तू पण होतीस.
मी कुठं, मी आत्ताच आली,
होय
5-10 मिनिटं झाली. नाही ग.
आज नाही, परत बोलते आता रेकॉर्डिंग होतंय. हो तर तोंड सांभाळून बोलायला लागतं.
व्हॉट इज सिस्टीम रोहित.
खरं आज बरकड सरांचा
नाही
बर्थडे कॉलेजमध्ये पाहिजे होता.
भागायला जातो.
सरांचा बड्डे आज.
हो, बरकड सरांचा बर्थडे आहे. येऊया
माहितच
का
नाही, विश
सरासनी
करायला
हे
पाहिजे.
ऍपला मीटिंग मध्ये.
ये की. करा
मॅडमने
की
फोटो
जॉईन
ठेवलाय
आज
की,
झूम
गाडेकर
मीटिंग कर.
मॅडमने ठेवलाय, परत साळुंके मॅडमचा आहे.
ऐका की,
हम्म.
झूम मीटिंग घ्या.
कशाला झूम पाहिजे
मग
तुला?
आपला क्लास ऍड व्हायला पाहिजे. बावळट गप बस.
जा काम करायला
हीच
पारू.
एमएससी तुम्ही एमएससी ला तुम्ही वाटताय तर काय असलं बोलल्यावर तुमच्या.
तुझं
जरा तर
सारखं
त्यात
तीच काय
सिन्सिअरिटी
असतं रे.
पण आहे का तुमचं? आपण आता शिक्षक होणार आहे, असलंच तुम्ही पोरांना शिकवणार आहे का?
शिक्षक.
माय मीन्स ऑफ टीचर.
बरं चालतंय, बाय, ठीक आहे.
रोया काय काढबा कुठे काय काय बाबा.
झोपलोय बाबा.
त्या उठल्या
म्हणलं
उठल्या का
काढबा
मोबाईल
कुठे
हातात.
ती कोणती असेल बघ, काढबा कुठे करत.
गप नाश्ता करू नको.
काय
नाश्ता खाऊ नको एवढा लवकर.
गडबा कुठे म्हणजे? हॅलो.
आज आपलं काय नाही ना, लेक्चर नाही काय नाही, दिवसभर मोकळच.
अगं कडबा कोटी काय म्हणते ती?
काय नाही, त्यालाच विचारत.
सांग की काय?
बेस्ट फ्रेंडला, तुझ्या बेस्ट फ्रेंडला विचार तूच
ए
आता.
गे पे बावळ. ही तर निवड डोकं पडलेली.
ए चला बाय बाय, मी जाते, लेफ्ट होते आता.
हो सगळ्यांनीच.